promised, I said that we were going to solve 5 questions on exponential equations. So here is question number 2. I have solved question number 1 in my previous video. So if you are just joining us, please hit that like button. Just comment. If you have any question you want us to solve, write it in the comment section. I'll also do well to share this post to people who are around so that they too can also learn our benefits. All right, let us go to this question. If you look at this question, it involves both the radical and the exponential function. All right. Now, the first thing I want you to know in exponential equation, whatever you are doing in exponential equation is working towards achieving either the same base or the same exponent. All right. So whenever you have a question in exponential equation, you must try to have your algebraic skills or algebraic manipulation. So it's needed. Now, first of all, I want you to remember the laws of indices. So for you to do well in exponential equation, you must first of all go back to your indices. Go and study the laws of indices. So all of them are applicable in solving exponential equations. Look at here. The law that we are going to look at, that's what we call fractional law of what indices. If I have x raised to power 1 over n, this law says that what? I am going to have the nth root of what? X. And this n begins from 2, 3, till infinity. So as the case may be, it must not start from 1. So n starts from what? 2. So what does that mean? It means that when we are having a question like this, we can change from this form down to this way, or can as well change like this to this. Now, if you notice something here, you will discover that we are having this type of form. We're having it here. So the first thing you need to do is to rewrite each of this expression in this format. So in that case, these are 4. These are 4 raised to power x plus 8. We'll be having, let us express it like this. It will become 1 all over, that is the exponent, 1 all over 2x plus 4. Now let us move to the right hand side. The same thing. It means 128. Then we have the 6th root. That is the 6th root of 128. Now let us take it step by step. Good. The next we are going to do now, we want to achieve the same base. That is our aim. Let us express this one to the lowest base. We also express this one to the lowest base. Remember that in my 128, if I begin to express 2, begin to multiply 2, number of times, couple of times. So it means that if I have 2 up to 7, that means if I multiply 2 up to 7 times, so it will give me 128, which means 2 raised to the power 7 is equal to 128. Good. I have expressed this one. What I will do, I will express this one here to this. Then in your 4, we already know that 4 is equal to 2 raised to the power 2. Good. Now let us express this 4 now to that, which means we're going to have 2 to power 2. Then because this one is already a power, then it will multiply it. That is x plus 8. Then we are having 1 all over 2x plus 4. Now let us break this one to 2 to 7. Then 1 over 6. And now let us go to the law of indices, where we have a raised to the power m, and are having n outside as the power. What you do, this become a over m n. Now this will multiply this. Now the same thing will happen here, okay? Which means this here will multiply by this power. We have 2 to power. Remember, this 2 is multiplying whatever is inside here in the bracket. So distribute this 2 to this here, becomes 2x. Then 2 times 8 gives us what? 16. Then multiplying this is a fraction, times 1 over 2x plus 4. That is for the left hand side. Now let us go to the right hand side. Become 2 to the power 7 times 1 over what? 6. Therefore, we have the base the same. That is our essence of solving exponential equation. Now, this one and this one, we can do away with them. We equate the exponents now. We now have 2. If this one multiplied, this one is a fraction, become 2x plus 16 over what? 2x plus 4 equal to 7 times 1 becomes 7 over 6. Now, let us let us cross multiply. We are going to cross multiply now. So a cross multiplication, we are going to have 7 into, because we are going to cross multiply like this, okay? Cross multiply 7 into 2x plus 4 equal to 6 into 2x plus 16. Now let us multiply. 7 times 2x gives you 28x, okay? 28x plus, oh, sorry, that's not 28, that's 14x. 14x, then 7 times 4, it will give us 28. Then equate it. 6 times this gives us 12x plus, let us multiply 6 times 16. 6 times 16 will give us 96. This will give us 96. Okay. Now we can collect the like terms now. Let's collect the like terms. So bring this one to this side. So whenever a term crosses an equation, it turns the sign. So there is positive, then becomes negative. That's 14x minus 12x equal to 96 minus 28. Now let us finish it from the top there. What we are going to have 14x minus 12x to give us 2x equal to, now 96 minus 60, okay, 96 minus 28 to give us 68. Then what you just need to do is divide both side by 2, divide both side by 2, divide both side by 2. So this one here, this here, then the next one, this here, that is what? 34. X equal to what? 34. So this is the answer to this question number 2. Now let us move on to question number 3. Stay tuned. Don't go anywhere. Grab a glass of juice and start chilling out as you watch me as I will demystify these questions on exponential equation. So let's get to question number 3. Okay, question number 3 says, this is question number 3. We have another question that has to do with radical x plus 0.5 roots 729 equal to, we have the x minus 0.5 root of 9. So we are asked to find x. Find x. Okay, so this is similar to the previous question we just solved. So what we just need is the same approach. We have already understood the laws, so we are going to change this one to the other form, which is now 729, then exponent 1 over x plus 0.5, then equal to, here we have 9 exponent 1 over x minus 0.5. So what we are going to do, since we have 9 here, there is always a relation between two numbers in exponential equation, just like which we have 2. So 2 is related to 4, 8, 16, 32, 64, as the case may be, as it goes up. So the same way, when we have 9, we have 27, we have 81. It means that 3 is related to all of them. So whenever you are working with exponential equation involving this kind of numbers, you should try to reduce them to the lowest base. So if 9 is the lowest base that we can find inside 7 to 9, we break this down. So the same thing, if 3 is the only base that we can find inside here, we will break it down. So let us go. In your 7 to 9, in your 7 to 9, in your 7 to 9, we can break it down to the base of 3. So if 3 multiply itself 6 times, if 3 multiply itself 6 times, we are going to have 7 to 9. And that of 9, we have 3 multiply itself twice. So here, we are going to use all these ones to replace this. So in your 729, please, the noise, reduce the noise, please. Okay, now, oh, sorry, those are my students. They're actually my students. So let's go. Now let us break this one down to this. So inside here becomes 3 raised to the power 6. Then we're having 1 over x plus 0.5. Then equal to here, we're having 3 raised to the power 2. We're having this another one here, which is x minus 0.5. Now let us go. So we remember this law of indices where we have a raised to the power m and we're having another power inside. It will give us a raised to the power m n. So we are going to multiply this now. So in multiplying this, this will give us 3 raised to the power 6. Then x plus 0.5 equal to, this goes there, this multiplies this, becomes 3 raised to the power 2 over x minus 0.5. Now we have achieved our aim. What is your aim? Your aim is working towards achieving the same base. So the base here, this base here, this base here is the same. So what we just need is to equate the exponents. We have 6 over x minus 0.5, then equal to 2 over x minus 0.5. Okay, now we can cross multiply. So if we cross multiply, we're going to have 2 into x minus 0.5, then equal to 6 into x. Oh, sorry. 2, this is plus here. This is plus. So this one becomes x minus 0.5. All right. You should always be very careful so you don't commit blunder. So now let us open the brackets. So 2 multiply x is 2x. 0.5 is sitting as half. And when 2 multiply 1 over 2, this becomes 1. Okay. So this gives us what? Plus 1 equal to 6 times this gives us 6x. And also 6 times 1 over 2 sitting as this cancel there are 3. So this gives us what? Minus what? 3. Now let us find the value of x now. We have obtained a linear equation. Calculate that. Let us move the x to the left side. Becomes 2x minus 6x equal to, here we're having negative 3 there, remaining negative 3 minus, take this one to the other side, becomes negative 1. Then we have negative 4x equal to negative 4. Then we can cancel out x equal to 1, x equal to 1. So that is the value to this question. So if you find this class very interesting, help us to share this post. Hit that like button. In fact, make una like, make una share. Don't waste time. Just a share as we move on to question number 3. Stay put. Don't go anywhere. Grab a chilled bottle of malt, a chilled bottle of juice. Begin to enjoy yourself as you enjoy the class. All right, let's move on to question number 3. All right. Question number 4, we have 2 raised to the power s multiplying 5 raised to the power x equal to 0.1 multiplying 10 raised to the power x minus 1. Then everything raised to the power 5. Okay, let us solve this now. Okay, now let us solve this question. So we have different base here. This base 2, this base 5, this is base 10 inside the bracket. So remember I told you that in exponential equation, every base must be the same. Now what does that mean? Look at this here. On my left here, there is a law in indices. If I have a raised to the power m multiplying b raised to the power m, we are having the same exponent. What it will give you is your ab, then having a common power. So this one here is related to this. So we are going to express this one in like this form. So we need to now give us 2 times 5. Then we are having a common power equal to, here is sitting as saying 1 over 10. 1 over 10, which is sitting as saying 10 raised to the power negative 1. So we are going to have it here. It becomes 10 raised to the power negative 1 multiplying, yeah, this power. We have a law that this one we have to multiply this exponent. Now give us 10 raised to the power 5. e to the x minus 1. Good. Now let us go. So here we have it 2 times 5 is 10 raised to the power x on my left. Then equal to, here, the same base. We are going to add up the power, which will now give us 10 raised to the power x, 10 raised to the power 5 into what? X minus 1. Then we have a negative 1 here. Negative 1. Please, you guys should go down. Go downstairs. Your noise is disturbing me here. Okay. Now let's go. What you do now is to cancel out. Okay. Cancel out the base. This base and this base, they are gone. We have x on our left side equal to 5 into x minus 1. Then we have another minus 1 there. Because remember the law of addition, which is multiplication here, we add up the powers. So we have x here equal to, distribute 5 to this, we have 5x minus 5, because 5 times 1 is minus 5, then there is minus 1 there. So this will now imply to us that x equal to 5x minus 6. Now let us collect the like terms to move this 5x to this side. So we have x minus 5x equal to 6 will be remaining there. That is negative 6. X minus 5s will give us negative 4x equal to negative 6. Now let us divide both sides by negative 4. So what we have here becomes negative 4x over negative 4, then equal to negative 6 all over negative 4. Now 4 cancels 4, negative cancel negative, then we have 3, 2 here, 2, that's 3 over 2. Now you can decide to reduce it to a mixed number, which will now give us x equal to 1 whole number 1 over 2. So this is the solution to this question. As you enjoy this exponential equation, please help us to share this post to get a greater number of students across this platform. Now let us move on to question number 5. Remember I told you we are going to solve up to about 6 questions on exponential equations. So let's go. 1 plus 2 raised to the power x minus 2, then plus 2 raised to the power x minus 3 equal to 448. Wow. When I first saw this question, I was scared. I was a little bit scared. Okay. But this question is very easy. In fact, we are going to trash the question. We're going to dissolve it. Haven't understood the basic laws of indices. So we are going to be applying it to this question. No, look at it here. Look at the common base. That is the most interesting thing we have here. But before we do this, I want to bring to your known, if I have a raised to the power m times a raised to the power n, what I will have will give me a raised to the power m plus n. So that is in this kind of exponential. You look at it now, we're having net positive. That means there's an addition of what? The exponents. Now let us look at this again. We also have, if I have a raised to the power m divided by a raised to the power n, it will give me a raised to the power m minus n. So these are the two laws of indices which we are going to apply to solving this question. And remember, we can transfer a question in this format down to this and as well do the opposite. So in this case here, it means for the first term here, 2 we multiply, that is 2 raised to the power x, is multiplying 2 raised to the power this one according to this law. That is 2 raised to the power 1 is sitting as 2, then plus 2 raised to the power x here, 2 raised to the power x here, because here we have this law where we have to subtract the power, so it means it's a division. So it becomes all over 2 raised to the power x. Then plus, here we have 2 raised to the power x. Also, we are also going to apply this law, which will now give us 2 raised to the power 3 equal to 448. Okay, who is watching? Please write your comments. If you love what I'm doing right here, do well to share this post. Okay, I promise you, I'm going to make exponential equation very easy for you. All right, now let's go to what we have here. All right, so since we're having 2 raised to the power 1 is setting as 2, so it's going to give us 2 multiplying 2 raised to the power x, all right? Then plus 2. Oh, sorry, this is 2 here, not 2 raised to the power x. Here we have it 2. Okay, this is 2. All right. Then if it now becomes 2 raised to the power x, 2 raised to the power 2 is 4. That's 2 squared is 4. 4 plus 2 raised to the power x all over 2 raised to the power 3 is 2 times 2 times 2 times 2. That is 3 times. It will give you 8 equal to 4, 4, 8. Now what we are going to do now is for us to remove it from a fraction. Let us make it a linear equation. What do we do? We are going to, okay, now let us look for the LCM of the denominator. The LCM here should be 8 because we have 8 as the highest number. So what you do now to make it to become linear, you are going to multiply through by the LCM. So multiplying through by the LCM, we will have 8 times this 2 here gives us 16. Then we have 2 raised to the power x here. 2 raised to the power x. Okay. Then if it comes here, 4 will cancel 8. Right? It gives us 2. That is 2 brackets 2 raised to the power x. Then 8 will cancel 8. Remember, if I have 1 over 4 times 8. So 4 here 1, 4 here 2. That is what happened here. Okay. So this one is written as saying 1 over 8 times 8. Okay. 8 cancel 8. So we'll be left with just 2 raised to the power x equal to, we have 4, 4, 8 times 8. Now let us multiply this 4, 4, 8 times 8. All right. Okay, because no calculator here, let's just work, keep on working. Now, if you notice something here, we're having 2 raised to the power s here, 2 raised to the power s, and 2 raised to the power x. So the coefficient of 2 raised to the power x here is 16. That's plus 2, 18. Here we're having just one of it. That's 19. So which means we're having 19, 2 raised to the power x, then equal to 448 times 8. Well, I don't have a calculator. That's why I'm simply doing that way. Now let us make this one, solve the formula by saying 2 raised to the power x equal to 448 times 8 all over 19, because we are going to divide both sides by 19. Now let us get a calculator and do that. So which means 2 raised to the power x now equal to, multiply this one, this, then divide by 19. Okay, it will give us, after division, it will give us 188.63. That's 188.63. So how do we get our x now? Because the base here, this cannot be expressed to base 2. The only way to get this x now is to express this one, or take the natural log of both sides, or express both sides to log to base 2. Now if I take the log of 2 raised to the power x to base 2, equate it to the log of 188.63 to base 2. So now, according to the law of logarithm, this power here, we have to multiply here, become x log 2 to base 2 equal to log of 188.63 to base 2. Now, in logarithm, if I have the log of a to base a, it will give us 1. So it automatically, the whole of this one becomes 1. We now have x equal to the log of 188.63 to base 2. So this is our answer. This is the answer to this question. So if you like what I'm doing right here, please share the post. Comment. If you have a question, write it in the comment section. While we move on to question number 6. For those of us writing, if you are writing, pause the video and write, okay? Because of time, let us go to the last question for today. This last question says, we have, that question number 6, we have 3 raised to the power x plus 1 minus 3 raised to the power x equal to 162. That's 162. So the same law which we applied to the previous question is still what we are going to apply. So this is plus 1 here, okay? So we still have that is a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. We are going to apply that to transfer this to this form, which now give us 3 raised to the power x times 3 raised to the power 1 is sitting at 3, then equal to, okay, here we have a minus 3 raised to the power x equal to 162. Now let us go. Here we're having 3 equal 3 raised to the power x minus 3 raised to the power x equal to 162. What you are going to do now, we're having a common thing here. Look, I say common factor here, 3 raised to the power x, 3 raised to the power x. So let us factor it out. So if I bring it out, I'm going to have 3 raised to the power x. Then 3 will be left here, right? 3. Then if I remove this here, it becomes 1 minus 1. Then equal to 162. Let's go. So we have 3 raised to the power x. Multiply 3 minus 1 is 2 equal to 162. Now let us remove this from here so that we can have this one separately. What do we need to do? We divide both sides by 2. Divide both sides by 2. So this one cancel this one. That one is gone. So 2 here is 16, 8 into 1. So which means we are going to be having 3 raised to the power x equal to what? 81. Now let us express this one to the base of 3, which will give us 3 raised to the power x equal to 3 raised to the power 4. And remember, 3 raised to the power 4 is not 3 times 4 in mathematics. It means 3 multiply itself 4 times. My children, is it not so? Yes. Good. Now let us go. So which means this one and this one can what? Disappear from there. So x becomes 4. So this is the answer to the question. I hope you find this class very insightful and also very interesting. Please help us to share this post now across various groups so that we can get to a greater number of students who are in need of this particular topic. And for those of you that are in grade 10, finding exponential equation very difficult, this is an opportunity for you now to learn. So I have decided to simplify it and break it down. But this one is a little bit complex. So there is another equation that I'm going to solve. Let me check if I still have some work in my diary. Okay.